Hello everyone, myself Kalachelvi, working as an assistant professor in the Department of Mechatronics Engineering, SNS College of Technology for past 10 years. Today we will discuss a very important practical topic that is a selection of power rating for drive motors. So in electrical drives, selecting the correct motor rating is critical. Why? Because understanding the motor which is overheating or failure like that, and overrated motors which is unnecessary cost and poor efficiency. So our goal is to choose the optimum power rating considering the thermal and load factors. So here power rating selection basics. So power rating is defined as the maximum continuous power a motor can deliver safely. So this selection of power rating is why is proper rating important, uh, is that is prevent thermal damage and then ensures the reliable operations, which improves the energy efficiency. So the thermal consideration includes the allowable temperature rise, insulation classes, and then cooling capacity. So we have to remember that motor rating is primarily limited by temperature rise. So the several factors influencing the motor rating selection is thermal overloading, load variations, duty cycles, safety margins, service factor, and insulation class. So among these, thermal overloading and load variations are the most critical in electrical drives. So before selecting a motor, we have to follow the design thinking approach of 5 stages. The first stage is empathize. So here we must understand the motor requirement and then require the power output and speed and torque needs. So application analysis of types of load, operating environment, load profiles, so peak load versus average load, and then nature of the duty cycle we had previous classes, and this step ensures we clearly understand the real operating condition. So next stage is define. If we have to define the problem here, so we determine motor rating by the by considering the thermal limit, load variation factors, duty cycle, service factor, ambient temperature, uh, etc. The selection criteria must be a adequate safety margin, proper insulation class, and then sufficient cooling capacity. So this converts application needs into a engineering parameter. Here thermal overloading factors. So let us understand why motor heats. So motor heating occurs due to the I square R losses in winding, that is current resistant loss, core losses, friction, and windages. So insulation temperature classes are: class A having the 60 degrees Celsius, class B is 80 degrees Celsius, class F is a 105 degrees Celsius, and then class H is a 125 degrees Celsius. So higher class means higher temperature tolerance. So the thermal time constant indicates the time taken to reach steady temperature, cooling time during the rest period, and then it is very important in intermittent duty motors. So now let us see load variations. So here a service factor, that is SF, is defined as rated power by actual power, which indicates how much overload a motor can handle safely. So peak load considerations are: we must account for the short duration overloads, starting torque requirements, transient load spikes. So and then RMS equivalent load, which represents the effective heating load. Why? Because motor heating depends on the RMS value, not just average load. Here this is the power rating calculation for three phase motors. P is equal to root 3 into V into I into cos pi. This is the power rating calculation of motor. So selection of power rating also remembers the kilowatt, that is kVA into power factor. The equivalent heating method includes the RMS load calculation, thermal equivalency, duty cycle consideration. So always check whether the duty is continuous, intermittent, and variable load. This is the ideal part. We develop rating solutions such as applying the proper service factor, providing thermal margin, optimizing the efficiency. This is a prototype and testing. We perform thermal performance test, load simulation test, and then endurance testing, efficiency measurement, so which validates our motor selection. Before finalizing the motor rating, we have to verify the service classes and then duty type, thermal margin, safety factor, ambient temperature, insulation compatibility, speed versus torque requirement, efficiency level. So only after checking all these should the motor be selected. So here we are coming to the recap and summary session. So let us summarize. So motor rating depends mainly on temperature rise. So thermal overloading must be carefully evaluated. So load variations requires the RMS analysis, and then service factor provides the safety margins. So here the proper selection ensures the efficiency and long motor life. So the final key takeaway of this presentation is always select motor power rating based on the thermal limits, not just mechanical load. Thank you.